session. I've already started recording and I'm creating a notes file which we can upload it and right. Where is that? It is not this one. It should be inside here. All right. We have 12 November. Okay. So if you have questions before the session starts, it would be better that you ask. All right. Feel free to ask the questions before the session starts. Okay. Today we are going to talk about the name node and more details. All right. All right. All right. So let's start. Hi Ali. Hi Arslan. Hi Barsa. Hi Jamil. Hi Jinyang. Hi Jitendra. Hi Karthik. Hi Kush. Hi Manjunath. Hi Nada. Hello Omkar. Hi Prashant. Hi Ramana. Hi Sapna. Hi Mishra. And hi Stephanie, Sundar, and Tad. All right, great. Great to have you back in the session. Sapna, are you able to hear now? Probably. Okay, let me check what's going on. The audio should be okay. Can somebody confirm that the audio is clear? Yes. Okay. All right. All right. Ramana, can you check your audio settings? All right. Wonderful. Wonderful to have you all back in the class. Very good question from Uh, Kush, let me take the question to the notes so that we can. All right, let me take the question to the notes. Question is, okay, yes. So question is, does Hive computes data slower than MapReduce since Hive is first converted into MapReduce? I will go into more details later. Here, my answer will be time will be approximately same. Okay. Why? Because the time that it takes to parse an SQL query and converts it into MapReduce is very small, maybe in milliseconds. Okay, while while MapReduce takes around minimum of 5 seconds to boot the process. Why? Because it needs to communicate and coordinate. Therefore, the time it takes to convert the SQL into MapReduce is very low, and therefore we can ignore it. Thank you, Jamil. All right, great, great. So, all right. So till last time we talked about HDFS, that the HDFS has name node and name node and many data nodes. It's the sysadmin which marks one of the node as name node, other nodes as data node. Okay. In case of Hadoop, when you're installing Hadoop using Ambari, at that time Ambari will ask you that which node do you want to make as sysad as name node, and which node do you want to mark it as data node. All right. Okay. So let me turn on my fan because yeah, just give me a second. All right. Now, when we are installing a Hadoop cluster, one of the node we mark it as name node and others we mark it as data node. If we are using Ambari, it will ask us, while if you are installing a virtual machine, it doesn't ask you because it is already installed in that virtual machine, and name node and data node both are on the same machine. Therefore, there is only one data node and one name node in case of virtual machine that people download and install on their machines. While in case of CloudX Lab, we have many data nodes and one name node. All right. A question from Kush: can we have same node as name node and data node? Yes, Kush. All right. Because a data node and name node is nothing but a process, and we can run two processes on a single machine, provided they they listen on different ports, because two processes cannot listen on a single port. Arslan's question is, have you seen any case where different language character set was not compatible with big data, meaning when we save file, it is not saving properly. So there are cases where when we are trying to load a file in Hive, if we do not specify the character sets properly, there are chance of errors. Okay. Yes, it's recording, Kush. Thank you. All right. Yes, Sundar. All right. So I hope that answers your question, Arslan. Great. Now, so we mark a node as name node and others as data node in a cluster. And sometimes we also put data node and name node both on the same machine. Then the name node listens to the first query from the HDFS client. So you talk to Hadoop using either HDFS driver, API, or the command. And this command first talks to name node, and then it talks to the data node directly and reads the data directly. Once, once it gets connected to the individual data node, then it transfers the file directly from the data node to the client, and that's how the overall process is extremely fast. All right, so that was our HDFS. The file is broken into blocks and so on, and every block is replicated. Those are the things which we discussed last time. Now, there were a few questions related to the single point of failure. All right. So before we jump into this, let me explain to you how does name node work. Name node keeps the whole metadata in the memory. And why so? Can anybody tell me why name node keeps it in memory? The entire metadata of the file system, it keeps in the memory. Correct, correct. So that people can read metadata fast, and therefore name node can serve to more customers faster. Now, on every change, if name node starts saving the entire metadata on every change in the metadata, if name node starts saving to the disk entire metadata, because metadata is a huge object, and if you change anything, if you try to update the entire metadata, it becomes difficult, right? It becomes difficult, and that's why name node keeps something called one image, meaning periodically we take the mirror of name node's image, and then we maintain the edit logs. Not we, name node maintains the edit logs. What does it mean by edit log? Every time we are creating a file, updating a file, modifying the permissions and so on, on every change, name node cannot update the entire metadata. Instead, it basically maintains something called edit logs. Okay, so if you have heard about a little bit of accounting, so accountant, instead of properly updating all the records in the accounting software for every change, they maintain something called journal. In journal, it's nothing but a log entry that, okay, this particular event happened. That's all. That's journal. And similarly, name node maintains something called edit logs. Okay, so at any point of time, if you want to recover name node, it is image which is periodically kept in the disk, image of the whole metadata or whole memory of name node, plus edit logs. These two things combined together reflect what is there inside the memory of name node. Okay, so if we maintain the image of name nodes, if we maintain the backup of image, we might be able to recover name node, but not the latest one. We would also need edit logs. We would need edit logs, and then let's say you have a name node, you were pretty happy, it was running. Okay, it was running. So what you did was you took an image of the name node's memory. It took some time, but it prepares the entire image of the memory. And then it kept on maintaining the edit log from the point when image was created. Okay, so that's how the name node used to recover from the crashes. Earlier in Hadoop 1.0, HDFS 1.0, the way we used to recover a failed name node was to take edit logs, apply on an older image, and then restart name node. Now this method was inefficient. Okay, and to avoid the failover of an entire machine, we used to keep backup of the image and the the edit logs. So name node, whatever is there in the memory of name node, we periodically used to create images of that one, and then name node will maintain the edit logs from that point of onwards. And whenever we want to prepare the recent one, we'll take the image and apply the edit logs. So Zeke's question is, when do the edit log merge into name node? When do the edit? They do not. Okay, every time we mirror the name node, that time edit logs are washed and then image is there, or we ourselves delete the edit log after merging. These are the two things, two times where edit logs get deleted or removed. Okay, so Manjula's question is edit log immutable file? It's not immutable file. It is a file that keeps on getting appended to. Okay, but it cannot be modified other than the HDFS login, so that not everybody, me or you, can tamper with the edit logs. Question from Sapna is, so generally, how many such images are maintained? So generally, we periodically keep on making the images, maybe every day or maybe every 15 days. Okay, because preparing the entire image is time consuming. Okay, so every time we prepare the name nodes image is like, set what do you say, regularizing the account. If you have heard the word, this phrase called regularizing the account, like accountant will come and sit for every week once and then regularize the account. That's like preparing the entire image. Okay, and edit logs are something like a journal. Every time something is happening, it's maintaining a log. Okay, so image combined, the image, let's say that was created in today morning, today morning 12 o'clock, we created an image, and then whatever changes that have happened since then, they go in edit logs, and we apply these edit logs on the image in order to recover a failed node. Because if the name node fails, whatever is in the memory is gone, right? The only thing we will be left with an older image plus edit logs. Okay, so using these edit logs and image, we used to recover the state of the name node's metadata. So there is a downtime. Good question, Aslan. So there is a downtime to recover the system, and there is no backup system which can take place of primary system. Wonderful question, and yes, that's unfortunately was true. In this kind of model, that was true. Okay. So Saptarish's question is, what factors to consider when designing the frequencies of merge? So we will talk about it in a while, okay? Because this does not, this is no longer a right practice to do, okay? Ted's question is it correct to have multiple name nodes and have the metadata replicated across the name node? Good question, Ted, and that's what we are going to discuss next. How does it synchronize metadata in multiple name nodes? Is it real time? Okay, that's what we're going to do next. Okay, Jamil's question is, what about secondary name node? Unfortunately, second name node was nothing but another machine on which there was, we have already set up name node, shut it down, and is not running anymore. All we do on that machine is, on the secondary node, name node, what we used to do is merge image with the log and start the secondary name node, okay, which was equivalent of the previous one. So instead of reinstalling name node, we already installed one name node on one machine, capped it as a secondary one, and whenever the name node goes down, we merge the image with the edit log, and then restart this secondary name node, and that secondary name node becomes the name node. So these two methods were older methods in Hadoop 1.0. These were the methods that we used to use for recovery. But now in Hadoop 2, we have far more advanced methods. Okay, let's take a look at this. Yes, thanks God, we have something. Yeah, thanks to actually Hortonworks, who basically built Hadoop 2. Okay, so yeah. Now, what happened in Hadoop 2 was a concept of standby name node came into play. Standby is just like a mirror of name node, just that it is standby. Okay, it's like somebody waiting there for the first one to fail, but it does not cater to any, it does not respond to any requests, as in it does not serve any users. The standby in the Hadoop 2.0, the concept of standby came into play. Standby is basically another name node which is not really serving any user. It's just there to maintain the latest metadata. Okay, and as soon as first name node fails, entire load goes to the standby. Standby suddenly becomes the name node the moment name node fails. Okay, the moment name node fails, the standby takes over. All right, so the important part to understand is there is name node and standby, and there are many data nodes, correct? All the data nodes are informing about the changes to name node as well as standby, so that the duty of name node to sync becomes lower, because name node doesn't have some of the load name node has given to data node, that it has the way it has been architected, that data node inform to both name node as well as standby, so that standby keeps the fresh data, very fresh data, and for the circumstances where name node goes down, standby becomes the name node. Okay, so standby is a hot backup or hot swap available at any point of time. Now, what does it mean by Zookeeper? Okay, so all right, so you see that there's end user. End user is using a client library the way you use Hadoop FS, correct? And this client asks Zookeeper. Zookeeper, you can always think like a whiteboard on which everybody writes their name. In your imagine there are two people who are supposed to handle the customer. Okay, the first one writes the name, or how should I say? Um, so Zookeeper essentially maintains the kind of attendance, and everybody keeps on giving the attendance frequently. If somebody does not give their attendance for some time, Zookeeper assumes to them to be dead, and gives the first slot to another. So name node as well as standby both keep on telling zookeeper that I'm alive, I'm alive. And till the point this happens, the first one will remain the usual zookeeper. In the zookeeper, first one will remain the name node. And the moment one of these nodes go down, the moment the moment name node goes down, let's say in this case, this name node as well as standby are updating zookeeper that hey, my name is name node and my IP address is this and I'm alive. Similarly, standby is informing that hey, I'm standby, my IP address is this and I am alive. So both of these are continuously updating. Now after a point of time, let's say name node goes down. Name node goes down, that means it won't be able to inform zookeeper, and after a while zookeeper will remove name node from the list, and therefore standby will become the name node. That's how zookeeper work. Okay, zookeeper is like a whiteboard where everybody writes their name and their names disappear after some time. Okay, they have to write their name again. That means that only the nodes that are alive, only their names will be visible on that whiteboard. Okay, so this is how zookeeper works. A very good question from Jamil. What happens if zookeeper dies? The answer is zookeeper is not a single machine. Zookeeper itself is running on many machines and it runs in a very interesting manner. And we would learn that as we go ahead. Okay, as we go ahead, we will learn what does it mean by zookeeper. All right. Okay. So the end user uses client library. Client library talks to zookeeper to find out who is the name node. Then once it finds out the name node, then it talks to the name node. Then name node tells about the metadata, and then client library goes to the data node and gets the data. Okay, does it make sense to you? Karthik, is your doubt cleared? Good. Jitan's question is, how long does Zookeeper waits for removing name node? It takes around 2 seconds or so. I think it takes around 5 seconds. I'll have to check the settings. Okay, we will test that out. Okay, I'll give you a demo that how does it remove the name. Okay, by testing using dummy data. All right. Ted, does that answer your question? Okay, Saptarish's question is there a latency in communication between data node and name node? Now the data node has to communicate to two sources. There is, yes, there is slight, you know, it takes a little more time in all these communication, but important part is that since data node has to inform two different hosts, therefore the load is actually parallelized and hence it becomes easier and faster. Okay, it becomes easier and faster. A question from Jamil is, it's like a load balancer pink from the server's right. Yes, it looks like a load balancer, but you will understand the difference as we go ahead. Okay, Zookeeper is more like a very lightweight database, central database, where everybody keeps writing their names. Okay, writing their data. So Saptarish's question is, even the standby node maintains metadata as images and edit logs. Actually, standby maintains edit logs and images, yes. Both of them will be maintaining their copy of the data, but their memory, okay, memory will be updated very frequently. Okay, name node will have its own image and edit logs. Standby will have own images and edit logs. All right, wonderful, wonderful. So moving ahead, in certain circumstances, in certain circumstances, what happens is, okay, let me again take a step ahead. So we have talked about the cases where name node fails. Okay, where name node fails, as in there is some problem with the name node and it shuts down. So we talked about two defenses against that. One was creating a secondary name node, and second was using the standby name node, right? But if you notice, that name node maintains the entire metadata in the memory, correct? It maintains the entire metadata in the memory. What does it mean? It means that if somebody keeps on creating directories and files, directories within directories and so on, name node's memory will become full. Okay, let's say you have a huge organization containing huge directory structure, and that directory structure contains huge number of empty files, or 1 KB file, 1 byte file, and so on. Now, when you have too many files, that means too much of metadata. And when you have too much of metadata, name node will need a bigger RAM. And let's say you don't want that. Let's say you cannot afford a RAM beyond 200 gigabyte. You kept on stretching your limits and you finally bought the highest available memory in the market, and that say is 200 GB. And still, name node is more hungry. It wants more RAM. Now, in those circumstances, you can split the metadata of name node into two name nodes. Okay, that's where, okay, that's where the idea of mount tables come into play. That's where the idea of mount tables come into play. All right. All right. So what happens is we create these configuration files called mount tables, and we save it on every node. And every time we have to change this configuration file, we have to update all the nodes. And this mount table contains the mapping that for this folder, go to this name node, and for the other folder, go to another name node. Right? For example, in this diagram, we show that for /MyData1, for all the folders under that top level folder, we are going to name node 1, while for MyData2 and MyData3, we are going to name node 2. All right. So that's the model. That's the model in the mount tables. Okay, that's the model in mount tables. Okay, and the other important part to understand about mount tables is that there could be many name nodes, but data nodes are same. Okay, data nodes are same. All right. A question from Prasant is, where is JK in federated mode? Good question. JK would have been here along with name node and standby. And interestingly, it's a very good point, actually. Thank you, Prasant. Okay, and let me try to put it. I think it's the good time to put it. So if you think about it, the discovery of name node or standby is going to happen through the, the Zookeeper. Okay, so you can see that. Good. So it's like central to the whole process. It's why do I see? Just give me a minute. I'll try to cancel this. And then, okay, so you can see here, all right? So it's like central to it. And the arrow has to be from all the nodes to Zookeeper, because Zookeeper does not call anybody. It's everybody who talks to Zookeeper. The reason why I want to draw this here, so that you know that there is always a single Zookeeper. Okay, so everybody is informing Zookeeper, and here we go. So the first consultancy for every client library they deal with is, first they talk. A client library tries to find out the mount tables file, and then once it has found the mount tables, it will go and check Zookeeper about the name node. All right, so you can see that all these, for everybody, Zookeeper is kind of centralized agent. Okay, I mean, it's so, Zookeeper is so omnipresent that we don't even discuss that it's it in most of the circumstances. All right, so name node keeps on informing Zookeepers, standby keeps on informing Zookeeper, and client library discovers about which one is name node 1 or which one is name node 2 from the Zookeeper, and so on. Correct? All right, good. There are a few questions which I've skipped so far. Okay. When standby becomes primary, then how is the next standby created? When the first name node, let's say standby became the primary, that becomes the name node. If the older name node comes back to life, that remains as standby. Okay? Does that answer your question, Sapna? And all right, so basically if the standby becomes name node and the older name node comes back to the life, the one which has come back to the life will remain standby and will not become name node. Okay, next question from Jamil. So if we have thousands of data nodes, do we need to maintain mount tables in all data nodes? All right, very good question, Jamil. Answer is yes. Answer is yes. Okay, that's why manual installation of Hadoop is generally not recommended. That's why we use things like Ambari, which reflect the same configuration across the cluster. Very great set of questions. Please pay attention to the questions because these are very important questions. Okay, now, so that question is, where is mount table maintained? Mount table is a config file that gets shipped to all the nodes. Okay. Because if the mount tables are maintained centrally for everything, client library will have to go to a central place. Okay? Because mount tables actually tell which name node do we need to talk to for a file. Therefore, they cannot reside on a name node. All right. Jamil, did I answer your question about the painful process? Yes, because that's mostly automated using Ambari or using your program. A question from Saptrishi: Why why would there be multiple mount tables? Shouldn't there be one mount table having configuration entries of all the directories to the name node mapping? That's a good point, Saptrishi. That question is that there is, yes, totally agreed that there should have been only one file containing the config, but this file has to be made available to all the nodes. If we put it on a single place centrally, let us say we create something called mount table server, whereby we put all the configuration file, and anybody who wants it, we will just let them query our server. Now, you see the irony? If we create a server on a singular machine, it's going to become singular, and therefore backup, failover, and other parts need to be planned. Correct? Therefore, mount tables are a configuration file, like a mapping file, and these get copied on all the machine. Same mappings have to be copied to all the machine. And as a programmer or developer, you have to ensure that part. Also, most of the mount tables do not get updated too frequently. All right? Saptrishi, did I answer your question? Wonderful questions. Okay. Mohit's question is, all the nodes including name node and data node? Yes. Okay. Mishra's question is, if JK, as in Zookeeper, has information about name node, then why mount tables are required? Very good question. His question is that we had already a Zookeeper kind of system. We keep all the information in the Zookeeper, right? The central information. Then why aren't we keeping this information about the mount tables in the Zookeeper? Answer is we should be. Okay, so maybe they are making these changes and it'll be a good design actually if we push these mount tables to Zookeeper. Okay, but since mount tables are really rarely used, therefore there's not rarely used, and if there are using people are using mount tables, we are hardly modifying these mount tables, maybe once in 2 years or so. Therefore there is not pressing need to basically make mount tables centralized. All right. Xinian's question is, Zookeeper is a single point of failure. Now, interestingly, Zookeeper is a very heavily distributed service, and therefore Zookeeper cannot fail. Okay, we will study this part. If you guys are interested, I can discuss Zookeeper now. Okay, so do you think I should just discuss Zookeeper now before we jump ahead? Okay. All right. All right. Okay, so actually, since we are talking about this name node, data node, I think it would make sense to discuss Zookeeper now. Okay, because every time I have regretted discussing Zookeeper later, because Zookeeper will come into play at many other places. Okay, and the other logical reason why I'm saying that we should discuss Zookeeper now, because Zookeeper actually doesn't depend on any of other services, while other services depend on Zookeeper. Okay, so because what we want to do is we want to understand why failover, because we all are right now in that mindset and we are thinking hard that what if this fails, what if that fails, and that's exactly Zookeeper helps us in doing. Okay, and you will also learn how name node and data nodes mechanism differs from the automatic selection. Okay, all right. So let me break from my usual routine, and just after HDFS, we are going to discuss Zookeeper for a little while. All right, everybody with me on this? Okay, I think this is a very good idea to discuss Zookeeper because it'll keep hurting us again and again. All right, now, so we talked about two things today. One, how to avoid name node becoming single point of failure. Second, by the way of uh, keeping the mirror of the image and the edit logs, and and maintaining a secondary name node, which both processes are very similar. And third is by maintaining a highly available T1, meaning using a standby name node. This is very much suggested mechanism. In this mechanism, the overall system performance is very good, and you can peacefully sleep. All right. I mean, for us, we are also working hard on bringing, the standby now bringing up standby on our CloudX Lab. Probably it'll be up in a couple of days. And all right, so again, a quick a refresher on the metadata part, that the metadata that we call is nothing but the name of the file, because data nodes do not know the name of file. They know only the block ID. Every block gets a block ID, and data node contains only that. The information such as the name of the file, what kind of replicas we have for a file, promised replicas and current replicas. Promised replica is something which HDFS has promised to you when you said Hadoop FS set rep 3. That means we are asking HDFS to promise us that HDFS will create these many replicas. Okay, it doesn't happen immediately. So actual replicas and the promised replicas, this number of replicas could vary. Okay, then the block IDs, the ID of the block, how many blocks have been created out of it, and which machines are they saved, along with the permissions, owner permissions, and so on. Those attributes are the attributes, those attributes of file are called metadata. Permissions, owner, name of the group, and so on. That is called metadata. The actual data is within the boundary of the file. Okay, actual data does not even contain the name of the file, name of the folder, what is the permission of the file, who is the owner, and so on. All of this is metadata. All right, so metadata is this. So a transaction log or edit log records the file creation, file addition, file deletion, and file changes. All right. Now, a common question which I'm facing from some of us is how to transfer the file onto CloudX Lab. Okay. So, I will try to show you this. Okay. So I have a laptop, MacBook Air. There is HDFS and there is a web console. For me, the web console is E. For you, the web console could be F. And for somebody else, web console could be G. Okay, web console could be G. All right. So for me, it is E. For you, it could be something else. Also, I have two home directories, one in HDFS, other is in Web Console. Okay, this you can see in Hue or using you. When you are on your laptop, you can open Web Console via browser. And in the browser, when you open, you are sitting on this computer in this home directory. If you're opening the Hue, you will be landing in this home directory. Your home directory will be your username, and my home directory contains my username. Okay, notice /user/home. All right, how to transfer a file from a laptop to Web Console? Web console as in the host on which you are running the web console. That's a real computer. Okay. So from laptop to web console, you can either use SCP, SFTP, or WinSCP. There are tools freely downloadable available for this. If you are on, say, Mac or Linux, SCP and SFTP will be available to you. If you are on Windows, you can use WinSCP. That's for transferring data from your laptop to the web console. Now, if you want to upload directly to HDFS, you can open Hue. In there, go to the file browser and start uploading or downloading data. Now, in case you have a file, okay, on your laptop and you want to take it to web console and you don't want to install any of this, you can actually do this. You can upload the data to HDFS, and when needed, you can download data from HDFS to web console using Hadoop FS copy from local. Okay, I hope this is very clear to everyone. Confused? So we basically have three places where we could be putting files. One in HDFS, other is web console, other is laptop. All right. So Nada, you need a little help. Why don't, okay. All right, not at all difficult. Okay, great, wonderful. All right, I'll show you this. So this is my laptop, okay? Let me show you this particular line first. From my laptop, I'm going to upload to web console, okay? And let me open the web console as well. Here is my lab, okay? From the my lab, I'll take my credentials. You can take the credentials from my course and all. All right, and here I go. Open the web console, copy the login. I'll increase the font size soon. Okay, good. Let me good. All right, now this is my web console. This is the web console. Also, let me open Hue. This is my Hue. I go to the file browser. Okay, so what you see here is, you see /user/home directory. This is my HDFS home directory. This is HDFS. Now, when I say ls, this is my, what do you call it? The web console. Okay. Here, when I say pwd, it shows me the present directory as /home, not /user. Correct? So we have three places. If I'm on the console, if I say pwd, it is entirely different directory. So there are three different directories right now. Okay, so the first mechanism here is copy something from laptop to HDFS, which we all know that we can click on upload and click on file, select the file from the local machine, and that's pretty much it. Okay, so all right. Okay, let me just see if I can. Mhm. Let me just put it this file. So you can see we have uploaded some file into this directory. It has been successfully uploaded. So the first one we have completed. Okay, first part, uploading from laptop to HDFS is done. Now let me show you something here. From laptop to web console. Okay, how do you do that? We use a command called scp. Okay, here on my laptop, let's say I am trying to say the directories that I have created, the notes I've created today. What do you call those notes? It's called November something. Okay, what is the date today? 12th November. Okay, 12th November. Now from 12th November, I'm going to copy this to my console. I'm doing this part. Okay, what is my console? My console is e.cloudxlab. Okay, and my login is this. This is my login. Okay, so I'm going to say scp the source file. Okay, this is where my source file is existing. Inside Google Drive, my big data classes, my learning classes, class notes. This is my source file. I'm providing my login e.cloudxlab.com colon. Okay, I'm saying copy this file to this host. Okay, it will prompt me for the password that I will copy paste. Now, this 12th November has been copied to my web console. Let me take a look at it. 12th November, you can see that it is there. All right. If I say Hadoop fs minus cat 12 November, what do you get? Can somebody help me? What will be the output? Correct. Error, because it's not there yet. No such file or directory. So now I'm going to use the third part, which is uploading from console to HDFS. So you can say Hadoop, not here, Hadoop fs copy from local 12 November txt. Okay. Yes, now you will see that it is there here as well. You can see it has come here. All right. Yes, that's right, Karthik. That's what I did earlier. If you see, what I did was in the web console, I did cat here, right? That's why it has printed this data, whatever questions we had, right? This is what it has printed. Now, if I say previous command, then it should give us the output. All right, everybody with me? So we basically followed this kind of diagram. Correct. Thank you, Arslan, for asking that question. In real time, yes, we do not keep any data inside either the local system or in the laptop. Okay, either on the web console here. Ideally, there should not be anything here. Whatever program that we want to run, we might keep it here inside the console, but whatever data we want to churn, we should keep it in HDFS. All right. Because in case this e.console goes down, something goes wrong with this machine, any data that you kept on the console will will be lost, right? We are not keeping a backup of this data. But in case you have kept your data on HDFS, in case this machine goes down, only the data node goes down, and your files will be recovered. So it's strongly suggested that you keep your data inside your home folder in HDFS. Okay, because if one machine or two machines go down, we'll have copies and so on. Thank you, Aslan, for that question. Good. So we basically will keep the data mostly in the HDFS. Yes? Yes. It's a normal Linux environment. This console, if you take a look at it, it's nothing but we can also SSH to this machine and start using it. It's a standard Unix environment. You can see that it's a Linux, basically a CentOS environment. Perfect. It's a Unix machine. All right. So that was it about HDFS. Okay. How to get the command prompt? Let's say how to get to the console. Either use web console, use SSH. On Windows, use PuTTY. How to create a file? Use if you're on the web console, you use nano. Nano is a command to do that. Okay. How to upload data into HDFS? You use Hadoop FS minus copy to local, copy from local. Where are my blocks? You can use a command called HDFS FSCK, and it will tell you where are the blocks. All right. So that was about the most basic system that we needed to learn called HDFS. Any questions related to HDFS? All right, very good question again. Thank you, Aslan. We are copying data manually here, and for sure, this is not the right way in real time. Then how do we do that in real world? Okay, we are going to mostly use Oozie, Scoop, or Flume. Or maybe a shell script. We will learn that part. All right. Good question. So yes, right now we are doing everything manually, but in case of a project, we would like to automate the entire process of copying the data, because copying the data, specifically big data, is not a small game. Copying the data is huge game. We need to have a great process. As I was telling you earlier, that so I was actually discussing with my friends at Yahoo earlier, because lots of people at InMobi came from Yahoo, and I was amazed to know that Yahoo has a team of around 30 senior engineers into a team called transport. And what they do is transporting the data. The reason is, when it comes to big data, the normal laws of transfer do not really hold true. Okay, normal meaning use the standard command to copy the data. No, we will be distributing the process of copying data, and that's what is the that's where the clever strategies come into play. Okay, and we saw it again and again that It might look very stupid in the beginning, but in reality, when you copy a lot of data, it keeps on failing all the time. And if you have few terabytes of data, with our usual tools, we will never be able to gracefully finish it. We'll have to come with a program, come with a strategy that in case this part fails, then next time when it should automatically boot and then do these steps. So mostly we end up writing a decent amount of workflow for transporting data. All right. Yes, that's right, Ali. We should generally upload our data into HDFS. Also, if you are uploading data into Hue, make sure that you do not upload your personal data, because our support team might take a look at it while providing you the support. If you get stuck somewhere, we might want to take a look at it. All right. So, so therefore, do not upload any personal data into HDFS or anything. These are very important questions, and I'm happy that you are asking these questions. A question from Arsalan. What is generally staging server? Where file landed? Okay. What is generally staging server? Where file landed? As in, so the way people do is they generally keep two kind of clusters. One, a small one, like we have a CloudX Lab, and another, a production server. So most of the work people practice and do on the sandbox cluster, and once that is working fine, then they start pushing it to the real server. Is that what your question was? I hope I understood it right. Okay. All right. So generally people have two set of clusters, and that's the reason why we created CloudX Lab, because at Amazon and everywhere we were given a cluster. Okay, while the people in the industry, they were all busy using virtual machines. Okay, because that's the one thing which we realized that was missing in the industry. Okay, now coming back to it. All right, so that was our discussion on HDFS. Okay, so as we had discussed, let's start quickly with Zookeeper. We are going to finish Zookeeper in 10-15 minutes, not more than that. Okay, we will try to do it more hands-on than than the theory. Okay, there's a very important piece of theory, and we would like to discuss it now. Okay, it's a very important piece of theory, and it took me a while to figure it out. Okay, uh, and I would love to explain those parts. All right, let me get the. Okay, so here is a question for all. Before we jump into anything, imagine that there are multiple email servers. There is multiple email processors. So typically, whenever we are say say processing email, indexing emails, or doing other magical things with the emails, let's say auto replying them and so on. Generally what we do is we process these emails using a network server. Okay, using various network machines. Okay, we call them processors. So I'll give you a true example. So when I was building this what do you call a document management system, we were actually accepting people's replying in the email. the way let's say you are a Yahoo group, when you reply to the Yahoo group email, that email get processed and appended to the forum, right? So that's where we need to process generally the emails. Okay, so when you're processing emails, you realize that the processing of an email is taking a lot of time, right? And you need to do this on many machines. So question to all of you is, how would these email processors avoid reading the same emails? Yes. So we have an inbox, okay, and we have these email processors. A question from Jitendra is, mark email as read. Okay, so now question Jitendra here is that, should it mark it read before processing or after processing? If it marks before processing and the email processor dies, then the email will remain read, and then yeah. All right. Yes, there are very wonderful questions. Now, the question is that we only have permission to either mark email as read, unread, and so on. We cannot delete the email. Okay, so most of your question is, let's have a lock or semaphore. Wonderful, wonderful. Okay, so but there are no locks on the inbox in this case. And other thing is that, let's say there's a program that is using, let's say, Java syntax for thread locking. Okay, let's say we are using lock keyword of Java or lock keyword of C or C++. Those semaphore or lock do not work if the two email processors are running on two different computers, right? You cannot protect yourself using the standard mechanisms provided by the language or the operating system if the two processes are running on different machines. Do I make sense to you? Right? And that's exactly why we need a central agency, right? So as Manjunath is saying that we'll use lock and a hash table to maintain. But question is, where will you keep this hash table? Each email processor 1, 2, and 3, these are running on 3 different machines. And hash table is in the memory. Yes. So we need a distributed lock mechanism. Yes, Kush. Yes, Kush. That's exactly. So we should use distribute it to different processors, and that's where the Zookeeper comes into play. Okay. So Zookeeper is like a central database where everybody can store tiny bits of information. All right. And as we saw earlier, somebody asked that, what if Zookeeper dies? The point is, Zookeeper does not die because Zookeeper is distributed. All right. So yes, Zookeeper is a very interesting design. And when it comes to big data, the truly distributed design is Zookeeper. Okay. It's truly distributed design. You will understand it why. It's a distributed coordination service for distributed application. It gives you very simple set of primitives, as in very simple set of commands to do wonderful things. It's very easy to program to, uses a data model like a directory tree. So first question would be in your mind that, okay, if Zookeeper is like a database, will it provide us tables or will it provide us something else? It provides a kind of tree structure in which you keep the data, like a file system, you keep the data, right? Similarly, it has a tree structure. It's used for synchronization, configuration, and coordination. It does not suffer from deadlocks and race conditions. All right, you can download it, or it's actually better to use in CloudX Lab, because here we could see it happening on the multiple nodes. Okay, in our case, we can generally start Zookeeper from the command line. All right, so let's first of all, before too much of theory, let's all of us log in. Okay, all of us log in and start our Zookeeper. Okay, yes. Jitan's question is Zookeeper used outside of Hadoop as well? Yes. Zookeeper is used by Kafka. Zookeeper is used by I think Cassandra and few more services. All right. Looks like there is something wrong about Zookeeper today. Did we shut down the Zookeeper everywhere? Because we were restructuring the organization of the Zookeeper. Oh, the two of the machines are dead, but it will still work fine. It's just giving warnings. It's just giving warnings. Let me log in into Ambari and try to restart Zookeeper server. Okay, so Zookeeper is installed on almost every machine. I hope the recording is going on. Good. All right, now since I've logged in from admin, I can restart two components. Okay, this one, heartbeat lost. Okay, that's okay, I think. That's okay. These two nodes are anyway not of any use. Okay, these two nodes have been put into that mode by choice. Okay, all of the machines purposefully have been shut down. Okay, so nothing to worry if it's giving the warnings. All right, so what's wrong with this? Unable to read. Ouch. This looks like it needs a little work on the E. So looks like it's not running. No, actually, it's not connecting for me. Let me take a look at it. All right. I think yes. All right. I think a better thing would be to try G. Okay. Well, let me open G or H. You can say G here in the terminal. Say g.cloudxlab. I mean, not 888. G, simply G. I think is Zookeeper is dead. Basically, that machine, I think they have changed certain configuration rules. I'll have to take a look at it. Basically, that machine is not able to talk to other zookeepers, and that's why it's isolated. Probably the firewall rules have been changed. Ouch. Okay, let me try. It doesn't allow me to log into G. Okay. All right, never mind. I think I'll take a look at it in a while, maybe after a break, or maybe, yeah. Okay, don't worry. I'll take a look at it a while later. SSH Sandeep at f.cloudxlab. That's the account which has all the permissions. When I say Zookeeper client, ouch. Actually, what has happened, we have created these new nodes, fresh new nodes, but we have not allowed firewall to let Zookeeper talk to other machines. So we'll have to allow 2181 and then it'll work. Maybe after the break. All right. So my plans of running Zookeeper before MapReduce are little off. Okay. So because I really wanted to show you while we all right. No, actually, more important than that is more important than me showing you was that everybody is able to do that, and therefore, it's not a great idea to do this. So let's do this thing. Okay, let's do this thing that just give me a message. Okay, let me just inform my support team. Basically, all they have to do is go to AWS. And allow that in firewall. Yeah. Okay. So G seems to be fine. All right. Let me see if somebody can, in the meantime, let me, show you if I can on SSH Sandeep at G dot. g.cloudxlab.com. Okay, Zookeeper client. No, actually, yes, here you can see this. And there, all right, good that we caught it, because we have been trying to set up a few things. No, it's not working. All right, never mind. So I'm going to go ahead with few things, and then, okay, I'm hoping that by the time I come to the hands-on exercises, everybody would be able to do this. All right. And maybe the idea that Jamil is suggesting, that we can log into his account and then use it. Okay. That is also not a bad idea actually for now. All right. So basically we start using it using Zookeeper client. So Jamil, could you share your login password in the chat so that everybody can log into this machine G, and then we are all able to do the hands-on here. Okay. We will change your login password after the session. Yes. Not this one. I mean the CloudX Lab one, the login password that you see here like this. Okay. Not the LMS one or your anything. Uh, or yeah, actually, yeah, actually, if you guys can log in using your own G account, that'll be good. Okay, because later on we change the policy, and everybody should be able to log into G. Okay, just open in the console G, and that should be good. Yeah, thank you, Prashant. Yes, thank you, Sundar. All right. Yeah, it's only me who for who it did not work. Okay. All right, that's even wonderful. So I'm using my another account, Sandeep at CloudX Lab. Yes, good. All right. So once you get the console, like this, instead of using web console, I'm using this terminal. Okay, so open the console, open g.cloudxlab.com, provide your login password, and you will see a console. All right. Yes, everybody is able to log in. And then once you are able to log in, start Zookeeper client. Yes. Everybody with me? So right now, this is called the Zookeeper console. When I say ls space slash, this is what we see. These are the nodes. Okay, these are the nodes. All right. So let's say I want to take a look at what is there inside /12 December. You see that there are further nodes here. Okay. And when I say this, there is nothing inside it. All right. So what we can do is to get the data from any node, we can say get, and it'll give us all the details about the node. Yes, do not panic right now because it's too much of information. Okay, So it provides us the command like get and ls. Here we can even say get slash. So again, here it's a file system. It's a folder. It's a kind of tree structure. The only difference is there is no files. Everything is a node. We call that Z node. Okay, everything is same. There is no file or folder. Here in this one, 12 December is one Z node and student is one G node. Okay, 12 there is, so every node can contain another node and every node has the data. We use the get command to get the data out of any node, whether it's slash or whether it's 12 December. You can see initial is the data. Okay, everybody clear? So we use ls command to see the children's of a node, and we use get command to get the data from the node. Okay, when we say node here, it means the conceptual thing is not really a physical computer. Node doesn't mean here, we are talking about something called Z node. Okay, the way we have folder, similarly G node. So slash is the Z node, slash contains 12 December, and 12 December contains student and so on. Yes, everybody is with me? Yes, this is kind of a key value store. So everything contains a value in the form of JSON. Okay. Who all is anybody wants to know what is a JSON? I think we have talked earlier. No. There is. I'm not sure if there is a way to see the entire hierarchy. Okay. Entire hierarchy. All right. Yeah. There is no way to see the entire hierarchy. All right. Now let's say this is a place where everybody is storing their data, including Hive, including HBase, including the Hive server, including the Zookeeper itself. Okay, including us. All right, there is something called Templeton Hadoop. I don't know what is Templeton Hadoop. Okay, it contains, what does it contain? It contains some more information. I'm just wondering, yeah, now since we have not set up the backup name node and HA as in high availability yet, therefore you do not see the information about various, the one which we were talking about earlier. Okay, so this is the folder structure. So everybody is able to see the folder structure, ls less and get. Let's say there was April 9 class and I want to see what was there. So I'd written some. Yes. Now let's talk about these nodes a little bit more. So, okay. So you can always think of it as like a high availability file system. That's a very important way to look at Zookeeper. Zookeeper, you can always look at it the way either the key value system or high availability file, highly available file system. A particular Z node, whether it's slash or zoo or anybody, can have children. Every G node contains children, every G node contains data. That is the definition of the data node, of the data model of Zookeeper. Okay? So Zookeeper basically forms a hierarchical space. The dot and dot dot kind of notations are not valid in this case. There is no such thing because every G node contains data. We cannot append the data. We can only replace the data. All right. Now there are various kinds of Z nodes, as in various kinds of the file or folder, whatever you want to call them, there are various kinds of Z nodes where it could be persistent or it could be ephemeral. The way we create a persistent node is by specifying, by saying create then the parent folder and and the name of the parent Z node and the name of the Z node, and then the data that we want to put in. Okay, and the data that we put in here, all right, so the data that we put in, the way we create, let me create a, right, create what's the class name? This class was started on 5 November, so I'm creating 5 November. Okay, I'm putting the name as okay, I'm putting the name as 2016 5 November class. Okay, this data that you see here should be in JSON format. All right, so you can see ls slash we have created 5 November. We can delete all of this. Okay, I'm deleting all of these. How do you delete? All right. Okay, so where is the 5th November one? Yeah, here is the 5th November one. So we can see what is there inside 5th November, and here is the data. All right, so all of you can create a child node in 5th November. I'm creating mine, okay, and putting, let's say, my surname in the data, and that's it. A question from, all right, let me, okay. All right. A question from Sundar is, sorry, I missed something. All right. Sundar, feel free to re-ask your question in case I missed it. Thomas' question is, what's the max data size per Z node? Actually, I'm not sure. I'll have to check it. But there must be a max size per Z node. Okay, let me make a note of it. All right. Next question is, can we write code for Zookeeper to function and modify? Of course, yes. Zookeeper provides a great set of API to modify data. Question from Arsalan is, what's the purpose of this node slash directory? Are they same as? No, they are not same as data or name node. It's just the name is called znode because it's a tree structure. So it looks like a nodes of a big tree. That's why they're called Z nodes. All right. It has nothing to do with data node, name node. As a matter of fact, it has nothing to do with Hadoop as such. All right. It's a conceptual idea. The way inside a folder structure, you have files and folders, right? To organize the data. Since there are many users of Zookeeper, and many applications would be using Zookeeper, so it provides a hierarchical structure to store bits of information in a tree format. All right. A question from, again, Jamil. What's the use of data in Zookeeper? Where is it used? Trying to understand the flow where Zookeeper data is used. Good. Just hold on for a minute and this question will be answered. All right. This is a very, very important question and that's what I'm going to answer. All right. Here we are trying to store a very simple information. Okay. It could be based on your business use case, what information we're trying to save. Okay, so right now, can you all create a subfolder here, the way I have created Sandeep under 5th November. Similarly, please create your own Znode and give it some data, whatever data you want to put in. Make sure that this data should be in the form of either JSON or a single string. Okay, so this is the command I use. Let me also create one more command, Sandeep Giri, and here I'm putting some array. Okay, array of values. All right, and when I say get 5 November, you can see. All right, let me see who all have created the node. So I can see, wow, Nitin, Sandeep, Stephanie, Ramana, Manjunath, Mohit, Jitendra, Tad, Barsa, Sandeep Giri, Sapna, Thomas, PK, Jamil, Sikh, Ali. Wonderful. Okay, Karthik is saying, I tried doing this command, create 12 this, and most likely because you have not left a space between double quote and slash, therefore it has given an error and it might have exited the Zookeeper command prompt. So you might have to restart Zookeeper command prompt. I'll show you what I'm talking about. If I, let's say, make a mistake in the command, let me show you. It won't, it won't, it won't. Okay, so you can see that it is not created. All right. Oh, wow. Yes, we completely forgot about the break. So just leave a space between, I'll show you. So let me, first you have to create the parent folder. Okay. Or we can actually go with what you did. Okay. Just that you have to leave a space between the two. All right. So you have to basically leave a space between this. All right. You see the space I've left? And remove the slash. Okay. Remove the slash. That's it. All right. Okay. Let's take a 10 minutes break. All right. 10 minutes break. Back by 9:51 p.m. IST. Hi everyone, should we start? All right, all right. Hi Jin Yang, how did it work? Did you make some changes or? All right, good. Okay, so we created, before the break, we created our temporary node, uh, sorry, our nodes inside 5 November. Probably everybody is able to do it. So no matter from which machine do you log in, I generally, whether you are from F, G, or H, the nodes will be same for all. Okay, Saptrishi is not able to log in G. Okay, let me check if Saptrishi can log in. Okay, what's the login as Saptrishi? What's your login? All right, all right, all right. Okay, good. So let's see. So Saptrishi, you have to provide the data as well while creating the node. Okay, you'll have to say create 5 November Saptrishi and then data. And this data has to be in the JSON format. Okay, this data has to be in the JSON format. It could even be something like this. Okay, it could be something like name Saptrishi. Okay, all right. And we could do, that's pretty much. So all we wanted to do was create a node. Yes. All right. Now this is what we call the usual node, which is persistent, meaning even if we exit Zookeeper, it will remain there. Okay. So it's not a temporary node. If the Zookeeper restarts or these machine restart, this node will be there unless explicitly deleted. That's called persistent node. Perfect. Now, there's an idea called ephemeral node. This node disappears. This node disappears if this node disappears if sorry. So this node disappears as soon as you exit the Zookeeper client, or your machine shuts down, or or your network connectivity breaks. So as soon as your network connectivity breaks or a machine shuts down or something happens, this ephemeral node will disappear. Okay, meaning as soon as the session is timed out or ends, the ephemeral node disappear. Okay, so I'm going to create one ephemeral node now by saying create minus e 5 November, and I'm going to say uh, sgeph, or let's do one thing. Okay, let's do one thing. 5 November, we'll create some first. Okay, first this kind of node 5 November eph, and all right, so we have create 5 November eph, meaning there is a node there is a normal node. This is not an ephemeral node. So whatever node you create for yourself, let's create under this so that we can clearly identify. So we have created an ephemeral node called Sandeep. Okay, we have created an ephemeral node called Sandeep inside this. All right, so create your own ephemeral node. I'll show you the magic now. Okay, so you can see that everybody has already created. And how do you identify it? There was somebody's question. How do you identify? You can say, let's say I'm checking Jamil's node. It says the ephemeral node, ephemeral owner is this. That means ephemeral owner is not 0, and hence it's a ephemeral node. Okay, if you take a look at this one, ephemeral node is 0, and therefore it is not an ephemeral node. Ephemeral owner is 0, therefore it's not an ephemeral node. Good. All right, so what you saw is that this node is there, right? This one. If I exit this, okay, I have just exited from Zookeeper. Okay, do you still see my node? If you say ls, if you say you use this command ls space this, do you still see my node called Sandeep? Did it disappear? It should not have disappeared yet. It will take some time to disappear. Okay, it'll take around 5 seconds or maybe 10 seconds to disappear. Yes, so it has gone. Why? Because my session is deleted. Since I exited, if I had, closed this window without doing anything, then also it would disappear. All right. So as long as ephemeral node remains there, as long as there is a session. So if I want to test whether any of you has your connectivity is gone, I can always monitor this particular this particular this particular what do you say, this particular Z node to see that who all have exited. Okay, so basically I can clearly take the attendance of my class, as in how many of you have truly opened the console, kept the console open, okay, by just monitoring this node. Okay, that means the coordination can be very, very good for various reasons, right? So now, I hope everybody got the hang of ephemeral node and persistent node. Yes, great, wonderful. Now, so we talked about two kind of node. One, where we created a node which will remain forever unless deleted. Second, which will disappear after some time. The third kind of Z node is sequential node, meaning it creates a node with a sequence number automatically. So when you say raise a ticket with your internet service provider, they give you a ticket number, right? Similarly, when an email is created by Gmail, when you compose an email and send to somebody, there is a new number given to the email. So the whole world works on sequential numbers. I built a document management system earlier, and what I found is that every document need to be given a sequential number. And creating sequential number was a very tough task, specifically when there are many clients and then when there are many users. when many people are trying to log requests to your issue tracking system parallelly, hundreds of them, and we have created many threads which will keep on updating database. If the sequential number is not there, it is going to, if there is no good mechanism to create sequential number, it would be difficult. So far, it has been the database. Using databases, we have been creating sequential numbers. But when it comes to distributed computing, creating sequential number is very difficult. Okay, so this is where the znode, sequential znode, come into place. The way you create the sequential number is you say create minus s, okay, and then you provide the let's say 5 November, and you provide a prefix. I'm providing the prefix C and provide some data. It has created a new node called C 0000029. What is 29? 29 is the running count of total number of nodes that have been created under 5 November. Okay, under 5 Nov, there have been 29 nodes created so far. Maybe they are deleted, but they were created. Okay. On the similar lines, if I say now pH and I put some data at the root level, a node has been created. That means at the top level, so far 146 nodes have been created. This is how this running count works. All right. So sequential number, again, I'll show you some more things. If I say like this, what does it mean? I'm providing an empty prefix. I'm saying that I'm not providing any prefix. You just put the number in the create a sequential node inside 5 November pH and put 00. So this is sequential node. So far there have been 25 nodes created inside NovPH, and therefore the sequential number is 25 generated. Yes, everybody is with me? So many issue tracking systems across the globe could use sequential node in order to generate the running numbers. Okay. Yes, everybody is able to create their sequential numbers. Let me take a look. Not ls minus l, I'm sorry. It's ls. Okay. So yes, we can see Mohit has created, and all right. So yes. Okay. So I can keep on doing this and it'll keep on creating new nodes. I can see there are other people who are trying to create parallelly, and therefore it's giving us, it gave me 30, then 32, 34, now 35. Yes, 37. All right. So you can see that it is able to manage, the parallelism, many users, and you will see the distributed as well as we go ahead. All right, so everybody clear about the three kinds of node? Okay, so this is how a user, a developer, looks at Zookeeper. Okay, so these are the ways you will be using to talk to Zookeeper. All right, now the other important part I would like to discuss is this. This is something very important because it not only talks about Zookeeper or Hadoop, it talks about a lot it talks a lot about the general distributed computing. Okay, because MongoDB, CouchDB, and many other databases has been designed on similar architecture. All right, so you can see that the architecture of Zookeeper is two modes, standalone and replicated. Standalone is running Zookeeper on a single machine. That's only for testing purpose. It doesn't serve really any any anything. It's of no use. The standalone is of no use. The part that is of more use is replicated. Replicate is something very important, and that's what people use in production. Okay, so replicated means that you have a cluster of machines on which we run Zookeeper. We have a cluster of machines on which we run Zookeeper. All right, and this cluster of machines is called ensemble. Ensemble, like your music concert. So you have an ensemble of machines participating in Zookeeper. So Zookeeper server is installed on all the machines, and then we turn these machines on. And these machines talk to each other. They are informed about each other actually, and then they start talking to each other. And once they are done talking, they elect one leader. The way all of the election works is known as the Paxos algorithm. Paxos was one of the very senior engineers at Microsoft who designed a truly distributed system for a truly distributed system and the design. And based on that, lots of systems have been designed so far, but that's a little too technical. So I'll try to break it down to a very simple way, because rest of the things you can infer. It's highly available. It tolerates as long as majority of these machines in ensemble are available. Meaning, out of 100, if 51 machines are up, the ensemble will work. The Zookeeper will work. Otherwise, it will not. Otherwise, it will basically shut down. Okay, so let me again take you through the architecture, why I'm talking about this. Although the up to the Z node, the knowledge up to the Z node that, okay, that you can create Z node and everybody can create Z node, and that's how we coordinate. Okay, that's how we coordinate and so on, right? Like we talked about. Okay, so we'll talk about the use case again. Okay, we'll talk about name node, data node in the context of Zookeeper, standby, and name node in a minute. All right, so let's look at the architecture. How does it work? Because it's important not only with respect to Zookeeper or Hadoop, but in general, distributed or big data computing, because it's not going to go waste. All the new systems are designed in the similar way. All right, so in case of Zookeeper, what happens is you install Zookeeper server on many machines. Then all these machines know about all other Zookeeper. All these machines know about all other Zookeeper servers. And as soon as they are brought up, as soon as all these machines are turned on, they start voting. A phase called voting phase starts. Okay, the voting phase starts and they try to finalize one machine who will become the leader. The machine that gets maximum vote, the machine which has latest data becomes the leader. Okay, so that's the distinguished member is called leader. There's only one leader, rest are called followers. Out of three machines, there'll be one leader and there are two followers. Okay, this phase is finished when majority of the other machine synchronize their state with the leader. They get the latest copy of the data from the leader, and everybody becomes on the same page. At any point of time, if leader fails, if leader shuts down, leader does not respond for few minutes, the ensemble will declare re-election. There will be a re-election and some other leader will be chosen, and this whole process takes 200 milliseconds. Within 200 milliseconds, the re-election starts and the process moves. Okay, so the majority, if at any point of time, in case there is no leader, in case there is, at any point of time, if there is no majority, meaning if you have 10 nodes in a cluster and five or less, five or more nodes are down, meaning six or less nodes, sorry, five or less nodes are available out of 10. If six or more nodes are available, then cluster will keep running happily. If six or more are available, in case five or less are available, leader will we will step down and nobody will become the leader. The whole system will become read-only. Now, one more thing, this leader, all the modification requests, all the modification requests are forwarded to the leader. All the modification requests are forwarded to the leader. The leader broadcasts the updates to the followers. Okay. So any modification people want to do, their request will be redirected to the leader. Once the changes are done at the leader, the changes are forwarded to all others and they synchronize their state. When the majority have saved the change, the leader says that, okay, commit has been completed, and the client gets a success response. The protocol for achieving consensus is atomic. Okay, achieving consensus saying that, okay, how many nodes have saved and so on. And these machines writes to the disk before memory. All right, so that's the basic architecture of the Zookeeper. Same is the architecture of MongoDB and others. All right, so you can see that so Thomas's question is, if so it makes sense to have one sequential node per parent node. I did not get it. It depends on your business requirements. Okay, all right. So Ramana's question is, are they dedicated machines? So these are basically, again, Zookeeper server is nothing but a process. A single machine on our CloudX lab contains many services. Okay. Now, very good question from Jamil. How do the client know which one is the Zookeeper leader? Client doesn't generally know. Client only knows few or one Zookeeper node. Client is a client library again. Client library does a lot of heavy lifting. Client library maintains the session. Client library keeps on informing Zookeeper that it's connected, and hence the session should be maintained. Client library is the one which gathers the detail about Zookeeper cluster. Okay, so as soon as you will send a request to Zookeeper saying, hey, I need to write this data, Zookeeper client will talk to one of the machines. Zookeeper server, Zookeeper client will talk to the server and say, okay, hey, can you tell me who is the leader right now? Then this guy will say that, okay, as per my last knowledge, this particular machine is the leader right now. You go and talk to him and update your data there. Okay, so that's how it works. Did I make sense, Jamil? All right, so this is the architecture. Now, again and again, we have been talking about majority. Okay, we have been talking about the situation where if 50% of the machines are not available, leader steps down. That's what we have been talking for quite some time. Imagine there are these three nice machines, A, B, and C. A was a happy leader. There were B and C who were basically followers. Now, after a while, A shuts down. Okay, A shuts down for whatever reasons. A is not available anymore. The question is, will someone become the leader? Yes. Correct. Because 2 is still a majority out of 3. Correct? Out of 3, 1 is less than half, 2 is more than half. Therefore, there will be a leader. Correct. A question I missed earlier from Ali is, doesn't this make a bottleneck if there is only one leader and everybody is talking to a single machine? So read requests are served by all other nodes. Follower as well as the leader responds to the read request. Correct? And only the write request, the change request is done by one machine. Because if there are multiple machines making modifications, it becomes impossible to have a consistent state. Okay, Manjunath's question is a very, yeah, thank you, Ali, for a brilliant question. Now, Manjunath's question is again another brilliant question. There will be a data consistency between leader and followers. Okay, there will be, so yeah, instead of saying that Zookeeper does not provide consistency, we say that Zookeeper provides eventual consistency. What is eventual consistency? That right now we know that some of the machine may not have got the latest data from the leader. Some of the machines would be behind, right? Some of the machines would be behind, but we know that eventually everything is going to be all right. Okay, so it provides eventual consistency, not immediate consistency. Okay, because immediate consistency in distributed systems is not really possible. All right, next is Prasant's question is, what happens if the synchronizer of follower was not complete and leader shuts down? Do we lose data? No. So here is the deal. You are trying to, let's say, create a node, okay, with certain data. You are trying to create a node which is a modification. The request goes to the leader, and the leader was trying to modify, trying to accept the change. Okay, but leader would only give confirmation to the end user when 50%, more than 50% machines are able to get the latest this update. As soon as majority persists your change, or let me reword, once majority of the machine save this change or synchronize this change, only then customer gets the data, gets the confirmation. Customer gets confirmation, only majority gets his change. Otherwise, he gets an error. So in these cases, customer will get an error, and therefore customer can try again, right? Did I make sense to you, Prasant? Okay, a question from Ted. If less majority so that the cluster becomes read-only mode, how would that impact metadata reliability? Metadata will become old. Okay, if the cluster becomes read-only, metadata will become read-only. Sorry, metadata will be available, but people won't be able to modify that. Okay, did it make sense to you, Ted? Okay. Jamil's question is there a command to see which is a zookeeper leader? All right, let me see who is a zookeeper leader right now. All right, I think in the client library, there is a way to find out. Okay, so let me see. It's an interesting question. And there would be some, okay, there is way to talk to this. There is an admin interface which takes the 4 characters, and then okay, let me find out. Okay, who is the leader in Zookeeper? Okay, it should be possible. All right. So yes, so you were all were right that there will be a leader in this case. Okay, there will be a leader in this case. Yeah. Yes, Saptrishi, I will explain it once we finish this part. And remind me in case I forget. This is a very important point. All right. So yes, in case A goes down, either B or C will become the leader. Correct? Either B or C will become the leader. Okay, now let's take a look at this. All right. Let's say first A went down and C became the leader. Now, after a while, B went down. Question is, will C remain the leader or will C step down? So question is, there was A went down, B went down. Now C is only left as the leader. So should C step down or should C remain as such? Okay, so after out of 3, there are only 1 machine left. So there is only 1 machine available as part of the ensemble. So will C go down or as in will it remain leader or will it step down and there will be no leader? So answer is C will step down. C will step down from leader and the cluster will become the read only. That's correct. Okay, that's correct. So now, so is everybody with me? Or let me rephrase this question now. Okay, there were, okay, 5 nodes. Okay, A to E. E was the leader. A, B, C got disconnected. Will E remain the leader? No, actually, E will step down because majority is gone. 3 out of 5 are gone. Therefore, only minority is left. Okay. Similarly, okay, let me ask again a similar question. There were six nodes, A to F, and E was the leader. ABC got disconnected. Will E remain the leader? Now, correct. E will not remain the leader because it's 50%, right? It has to be more than 50%. Wonderful, wonderful. Dad's question is, if the cluster is in read-only mode, will data node get a notification of state? Which data nodes are we talking here? Okay, so basically they are just the consumer. Okay, they are just the consumer of uh, of uh, of Zookeeper. Yes. So both your questions I will talk after a while, Tad and Mohit. Okay, I would love to answer your question. Just give me a few minutes. Okay. So Jamil's question is, what happens in case there is no leader? We have only the followers. In those cases, the cluster is only read-only. It won't accept any changes. Good. All right. So doesn't it bother you that even though out of out of 6 nodes, we have 3 nodes available, right? Out of 6 nodes, we have 3 nodes available, and still our cluster is read-only. Does that bother you? Because the point is that I have 6 machines and still it's not available. And imagine that we had, say, 20 machines, and only 10 are available. 10 are available. Still no election, right? We have 10 machines available and still no leader, no election, and therefore my whole cluster is useless, right? Why is it so? Why this kind of majority kind of model? What exactly is that pressing need? Why exactly is that pressing need of having majority? That if majority is not available, the whole cluster cannot accept any changes anymore. This is okay. Yes. So my first concern is why 10 machines are unavailable. But if you think about a system admin, look at the cluster and say, my 10 machines are still available. It should just function and cater to the users, right? All right. So Ted's question is, should it auto configure to change its majority number? Very good question. And we will answer this. Okay. These are very important questions. That why do we need majority? Why do we need all of this? More than 50%. Why? Okay. All right. Let's try to answer it. And probably this diagram will answer you. Imagine that you had these 2 data centers, 1 and 2, containing total 6 nodes. 3 nodes in data center 1, 2 nodes in data center 2. Okay. Okay. Now, let's imagine that the connectivity between these two data centers is cut. The leader was in data center 1, leader was there. Now, let's say connectivity got disrupted between the two data centers. What will happen at this point? Imagine there was nothing like majority. Let anyone win, whosoever gets the maximum number of votes. Let anyone win, whosoever gets the maximum number of votes. Whether, okay, if there was no such clause as majority. So what would happen is both the data centers will choose their own leaders, because in case there is no majority rule, data center 1 as well as data center 2 both will have their own leaders, and that will cause the inconsistency which cannot be reversed. Why? Because if there are two leaders are accepting changes from different users. One has modified a node, other has deleted a node, and and after a while, the second one has renamed it, and first one has created a fresh new node with the same name. Now, you see the chaos with two writers, and that is why there has to be more than 50% votes in order to have an election, in order to select a leader. Because there can be only one circumstance, there can be only one partition of a network. There can be only one partition of a network that is majority. Therefore, there can be only one leader as long as we follow the majority rule. Okay? Did I make sense to you? Yes, let me answer to Thomas. So Thomas' question is, do these data centers have same number of nodes? No. Okay, they could have different. They could be many different data centers, right? Imagine you have three data centers. One is having 4 nodes, other is having 5 nodes, and other is having 10 nodes, right? Now, when when the fourth one and fifth one get disconnected, okay, 4, 5, and 10 are kind of connected. Okay, how do you draw these nice graphics? Okay, so yes, so the way, yeah, so 4, 5, and 10 are, let's say there are three data centers, one containing 4 nodes and other containing 5 and other containing 10. Now, so leader could be, as long as there is a connectivity, leader could be at 4 or 5 or and so on, right? Imagine that fourth data center got disconnected from the rest of the world. Okay, so this one got disrupted, this got disrupted, similarly this got disrupted. Okay, so now 5 and 10 are connected, right? Which is 15 out of total 10 plus 5 plus 4. 15 out of 19 are available. They will have an election. Now again, let's say this got disrupted. So now there are 3 islands. All the 3 data centers are now disconnected. Now what will happen? Can somebody tell me? Data center A, which has 4 nodes. Data center B, which has 5 nodes. Data center C, which has 10 nodes. Yes. C will have election because 10 is more than 50% of 19, and therefore there will be a leader in this particular data center, while these data center will have no leader, no election. Yes, I hope this is clear to everyone. All right. It's a very important aspect. Whenever you think about these distributed systems, this will come into your mind. Okay, and it should come into your mind. Yes, Thomas. But why is the better? Okay, why is this better as the example before? I was just trying to give you another example. That's it. All right. So yes. All right. So that's the way it generally works. All right. So now I'm going to talk about the use cases. The use case is, let's say there are many clients wants to connect to an array of servers. These are all the servers which are providing the response to the end user. Okay. Now, the first use case is coordination, because these servers cannot really keep track of all, sorry, these clients cannot keep track of which servers are up and which servers are down. Therefore, there is a middle layer called Zookeeper. All the servers will keep their the ephemeral nodes. These ephemeral nodes created by these servers will contain the IP address of the server. Okay, and as soon as this server goes down, the ephemeral node disappears, and therefore Zookeeper will not give the details of the servers which are down to the clients. So client come to Zookeeper, say ls minus l servers. In that list, only those servers will be there. In that list, only those z nodes will be there for which the server are up. Okay. So this is the reason. So all servers give their attendance to Zookeeper in the form of ephemeral z nodes, and all the clients query and find out about available servers from the Zookeeper. So that's the first way of coordinating. All right, let's look at it. Imagine there were two machines, duck and cow. Duck and cow. Okay. So first node came into play and talked to Zookeeper and said, create duck. Then second node came up and told that, okay, create cow. That cow is the name of second node, and so on. These are two machines. Now at this point, when user comes or the client comes and says, can you give me the list of servers? It says duck and cow. Okay. Now client comes after 5 seconds of duck server killing, and at that point of time, cow will not be available. Sorry, duck will not be available, not cow. So first time when the user came and said, okay, give me ls servers, it gave duck and cow. After a while, when duck got killed and the client came, when it again the client said ls servers, it gave only the cow. Okay, so you can see that this is load balancing. This is automatic load balancing, right? Similarly, imagine that instead of a duck, let's say there was a name node. Okay, there was a name node. So first name node came along. It gave the entry, kind of created an ephemeral node, and there, before creating it ephemeral node, it checked whether is there any other name node available. If yes, then the newly registering name node will become the backup, or you can say the standby, right? If there is no other name node, then the current name node will become the main name node, and that's it. So that logic is built into name node's logic. Name node goes to the zookeeper, checks whether is there any other name node registered. If it's registered, then this name node will mark itself as standby. Okay, and so on. In case there is no name node available right now, it'll check whether is there a name node. If it's not, there is no name node registered yet. Therefore, this new node will become the this node will become the name node. All right, so that's how the swapping will keep on happening. Did I make sense to you? Was I able to answer your question? The question that here? No? Wait. Hello? Are you able to hear me? Okay, so all right. So was I able to answer? No. I think Mohit has gone to sleep. Okay, I'm talking about, okay, let me actually draw. Okay, so let's see. Yes, Arslan. All right, let me just try to show you this, because this is kind of important at many places. Now let's talk about this. This is your ZK, and it has already a node called slash. Okay, it's called slash. Let's say name nodes, or you can say name nodes HA. Let's say this is the top level C node under which ephemeral nodes are created. All right. Now, first name node came to. Okay, this is the first name node. First name node says, okay, kind of give the attendance to JK. First, before that, it checked. The first call would be, okay, find out ls slash name nodes HA. Okay, that's the first call that it makes. Make sense? Now it responded that there is nothing. Yes, there is nothing available. Empty array. Okay, nothing. I'm replying. Next is the next call would be create ephemeral node, create minus e, okay, and minus e, and give the IP address, say 121 and its IP address, the name node, this name node, okay, like this, and mark it primary. Okay, so it created a ephemeral node called this and marked it primary. Now, same thing, imagine that same thing is happening again. Imagine that there is another name node number 2, okay, name node 2, okay, because admin is not marking anybody as highly available, sorry, admin is not marking somebody as name node or somebody is standby. Now let me see the name node again. It will say give me name node HA. It responded, the JK responded saying, okay, we have one thing called this particular. Okay, makes sense to you? All right, so it responded with this array containing only one element. Then the name node will respond and say, okay, then create minus e 121.131.11.2 and mark it standby. All right, I'm just giving an example. This is not a real code. I'm just trying to explain with the case. Okay, so Ted, was I able to answer your question? Okay. Aslan's question is, can we take some real-time example and then can you explain how to follow each level? Did I explain this is good, Arslan? No, actually, yeah. Because this thing took me a little while to basically figure out. Okay, so if you're slow, it's actually good. And yes, take your time. Yeah, we can have random data. That's not a problem. But this is something that everybody has agreed. Okay, that we will have. I'll show you. In the similar way, if you take a look. Okay, so we have, let's say Kafka or Hive server. Okay, you can see there are two server URIs here. You can see there are two Hive servers right now, and the requests keep on switching between the two. If one server goes down, you can take a look at it. This is a real data. All right, this is a real data. The name of this server, this particular node is interesting. Okay, so I'll show you this. So it's basically, if I say get, it gives me the detail that, okay, it's an ephemeral node and it contains this information. So there are two Hive servers, and our users keep on switching between the two comfortably. And the whole balancing is done using Zookeeper. Okay, I hope I made sense. So you can see that there are two servers. One is 154 running on 154, other is running on 158, and so on. All right. I hope these examples were useful, because as you see that Hive, HBase, name node, data node, everybody is using Zookeeper. Along with that, the design of Zookeeper is inspiring to many. For example, MongoDB, follows the same design, and many other systems follow the same design. MongoDB also has the majority rule, election, and replication. Okay, so it'll come to you automatically. Okay, now there are, all right, so I hope this example made sense to you. All right, I will not go into too much of details. Okay, with this kind of knowledge, you should be able to figure out a lot of things about Zookeeper. So I'm going to skip a number of things. Okay, right. So somebody was asking me about the who is the uh, leader. One way is to check by NC localhost and say 2181, and then you could say, are you okay? It says I am okay. So that's another way to talk to it. If you want to find out, you could say, okay, you could say CONF. So it shows you the configuration of the system. All right. And you could also see the environment. Okay. So it shows you the complete environment. And there is some more thing like statistics. Okay. So you can see that the mode is follower, the current one. And okay. So these are, okay, let me just see if we could. All right. I think this is the better way. If you say SRVR, this command should help you. Okay. So you can see that. All right. I think this is the node that is having the this is the node. Okay. This is the user that is the. Let me just check if my server is in read-only mode. It's read, right? Okay, so you can see that there are these commands using which you can actually find out, but still we could not find out. Okay, we actually could not find out who is the leader right now. All right, we could not find out the leaders from it. Okay, so that's 2181 is the port, yeah. All right, so I'm going ahead with few more things. So today's discussion is generally good enough for you for most of the class, and I would like to highlight few more items into this. Okay, there is something called triggers. Okay, although I'll just go over most of these important aspects. All right, there are many guarantees which Zookeeper provides, such as sequential consistency. Update from any particular client are applied in the order. That means the sequence of the things is maintained. Sequence of changes are maintained. Atomicity, updates either succeed or fail. Next is a client will have single system view, will not see the inconsistent data. Once the update has succeeded, the change has been saved. It cannot be undone even if the whole cluster shuts down. Okay. Next is it provides the timeliness, as in rather than allowing a client to see very stale data, a server will shut down. For example, E and F were not able to communicate with the cluster. Therefore, They were not giving us the response. When we said ls space slash, they did not give us any result. Instead, they exited. Therefore, in case one of the machine is really old and isolated, it would rather shut down than giving the response. That's kind of suicide. Okay. Rather than serving as stale data, it will choose to give an error. That's a very important aspect. Next is it provides the permissions. So take a look at if you are really interested in building an application on Zookeeper, take a look at permissions. There are ways of securing Zookeeper. Okay. It provides in the API, it provides you a way to batch many things together, say create this, create that, just like the database transactions. There are many APIs provided. Out of that, uh, Java and C are core, while all others are just wrapper. And every function, whether creating a node or checking whether it's something exists, for every function, there are two versions in API. Some are asynchronous, some are synchronous. Asynchronous are those which return immediately but call your while once they finish, they call your callback. Okay. So, and next is they provide Zookeeper provides watches, meaning you can tell Zookeeper to give you a callback once something is done. All right. There are many kinds of triggers. For example, the triggers that you configure in the function called exist, it will give you basically give you the alert, give you the callback when a particular node is created, deleted, or updated. So basically, Zookeeper provides you a way to call back. All right. All right. Now we have talked about this. Now this is important. Before we exit today, before we stop today, here is an important part. Do not use Zookeeper to store bigger data, because every the whole data is copied to all the nodes. Also, the whole data is kept in the memory. Therefore, if you keep on increasing and adding more and more data, Zookeeper is going to consume a lot of memory as well as a lot of disk. Therefore, make sure that you use Zookeeper only for tiny bits of data, not huge data. All right, this is important. Okay, so a question from Karthik. Will there be a need for a developer to write for this in any live real-time companies projects? Yes. I have not worked with Zookeeper, but there are many use cases for Zookeeper to be used. Okay. There are many use cases when you're building a product. Specifically, product companies will be using Zookeeper a lot. As you can see, there are, for example, Kafka developers, they use Zookeeper. Similarly, Spark developers, they use Zookeeper, uh, and and same is the case of with HBase. HBase also uses Zookeeper. All right, good. Thank you, Jamil. Because HBase, again, we'll talk about it, and yeah, that will be good. Did I miss somebody's question? Kush, yes. We'll not be discussing Zookeeper further. We'll not going into detail anymore. This will be good enough for the course. All right. Okay. So, all right. Thank you, everyone. I am 4 minutes past, and yeah, sorry for being little beyond timeline. So feel free to ask any question. Did I miss anybody's question, by the way? All right. Great. Thank you, Nada. Thank you, Kush. Thank you, Arslan. Thank you, Mohit. Thank you, Ramana. Thank you, Zinyang. Thank you, Ted. Thank you, Manjunath. Thank you, Omkar. Thank you, Zitendra. Thank you, Zamil. Thank you, Anup. Thank you, Ali. Thank you, Sheikh, Nitin, Thomas, Sapna, Karthik. All right. Bye bye, everyone. Have a great day ahead. I look forward to see you tomorrow. And I look forward to have a better participation than today. I totally enjoyed your questions and keep the questions coming because those are very useful. Yeah. All right. Happy birthday to Salesh. Okay. Okay. How do you know that it's birthday for Salesh? All right. Okay. Great. Oh, okay. That's my cousin, so I'll have to call him probably. Okay. Okay. Bye bye. Have a great day ahead. I look forward to see you tomorrow. All right. Bye.